Hey, in this video, we're going to look at overlaps and some ways of fixing them. An overlap occurs when one object is showing through another object. In our case here, the overlap appears on the left thigh. They can also appear when a character is in motion, for example, when they're running or jumping. And now I'm going to get our character to jump. And I'm going to slow-mo him. And you can see an overlap in the elbow area. And also there's a couple more on both knees. Some assets tend to get overlaps near the joints, and they're a very common occurrence when working with clothing assets. So it's very important to understand how to get rid of them. I'm now going to switch to running and play it. Then I'll put it in slow motion. And there it is. A huge overlap on the right thigh. Basically, there are two main approaches to dealing with overlaps: destructive and non-destructive methods. A destructive method involves altering the model itself through changing shape or size, modifying or deleting geometry. Currently, this method is used to fix overlaps in metahumans that are outfitted in the Metahuman creator. And this is an example of such a model. We're going to load the body now, and you can see that some body parts are missing. It is a legitimate solution to overlap issues, but it limits further customization if needed. And we're going to touch on the destructive methods of fixing overlaps available in UE in the upcoming videos. But in this one, we're looking at the non-destructive methods, which don't change models but alter the way they're displayed. And they can be divided into several categories: opacity masks, morph targets, world position offset, and deformers. We're focusing on opacity masks today. Opacity masks are black and white textures that mark specific areas of a skeletal mesh for use in materials. They are applied to a character's body material. And this is where an opacity mask should link. To show you how it works, I'll plug one of them into base color, click apply, and this is what it looks like. Before you apply opacity masks to your character's body material, make sure that the blend mode is set to masked. As by default, it is usually opaque. So once you've selected masked, an opacity mask socket will appear in the body node, where you'll link opacity maps. I'll grab this jacket mask here and plug it into opacity mask. Then save it. And now the part of the body that was painted black on the opacity map is hidden. And now I'm going to do the same for the pants now. Now you can see the parts that are supposed to be covered by the pants are missing as well. You can easily blend opacity textures by simply multiplying them with one another. In this example, this lerp1 node is linked to an external parameter that I can manipulate through the blueprint. Then I multiply this map with a similar unit of the shader and then link the resulting node to opacity mask. This allows me to adjust material parameters in real time. I'll open a material instance. Then I'll check these opacity boxes. Then I set is boots on to 1 to hide the feet. And we can do the same for other parts as well. And that should do it for this project. It's worth noting that opacity maps in our projects are designed exclusively for metahumans and our presentation characters. The opacity maps are based on a character's UV layout. Here's what a UV layout of our character looks like. It's nearly identical to that of a metahuman, which means opacity maps designed for one of our characters will work perfectly for metahumans. However, if your model's UV layout differs from a metahuman's, you should not expect great results there. And if you intend to use our assets on your metahumans, remember that by default, the blend mode in metahuman body materials is set to opaque. And one thing to note, also locating a body material isn't always straightforward. So to find it, I'll load our metahuman's blueprint, go to body, browse to body synthesize simplified, right click it, find parents, and find parent again. And I'll load this skin material. And under material, we have to change blend mode to masked. Here I want to add that all metahumans share identical opacity maps. So creating an opacity map once should work across the board. Though it's not going to hurt to double check this, as some metahumans can be radically different when it comes to 3D modeling. You can design your own maps with other image editing or 3D computer graphics software. Creating them in Unreal Engine is quite challenging. That's why we use Blender for this task. And that's it for now. I'll catch you in the next one.